You have been lied to. And this lie has not just been told to you, it's been told to pretty much everyone. It's a lie that a lot of people don't know is a lie. A lot of people will currently believe that it's true and will believe that it's true, and there's not really much hope for change. This lie is that we live in a three-dimensional world. On the surface, it seems like this would be true. I mean, you can't see a fourth dimension. We have no definition of a fourth dimension. Some people have argued that time is a fourth dimension, but until you get to the point where you can actually see and fathom a dimension beyond what we know, there's no proof of its existence. There's just a proof of theory. So, why do I say it's a lie? Well, pretty simply. There's two, well, arguably only one, really good example of how we function in a system that's not what we believe, or not what we've been told. So I'm basically just going to go into the one that's a lot easier to prove. I don't really want to waste your time with the second. I'll do that at a separate time when I have a lot longer to give for this kind of talk. So, light. The moment I say that, everyone is immediately having flashbacks of their high school physics courses, and they don't want to hear it anymore, and I'm just going to let you know I'm not going to go into any of the relativity and stuff. I'm just going to give some basic facts that are known about light, and talk about their mathematical implications. So basically, light has all sorts of weird, fantastical properties, one of them being that no matter how fast you're moving, up to a certain point, if light passes you, you will record its speed the same. If I'm standing still and you're in a car going 70 miles an hour and we have the most accurate measurements possible to measure light, we will both measure the speed the exact same. So it's not speed dependent upon observer. The problem with this is that we understand the world around us geometrically by Euclidean geometry. Euclid was a mathematician who came up with much of the principles by which we use. In fact, three-dimensional space is three-dimensional Euclidean space. We just kind of leave that word out because we don't understand or fully comprehend spaces that are non-Euclidean. So you have the x, the y, and the z axis, and that is Euclidean space, and everything that we know is encompassed within this Euclidean space, except light. For Euclidean geometry to hold, certain things must hold. If I'm moving at a certain speed, and an event, and you're standing still where I started, and an event happens over to the side of both of us, the fact that I'm moving should impact my measurements of this event. And light, it doesn't work that way, whether the event is to our immediate right, to our immediate left, whether the event is coming towards us, whether the event is going away from us. If I am going forward, and you're standing still behind me, we will have the same measurements. This doesn't abide by Euclidean laws. So what does this mean? Well, since light exists, I don't think anyone could really argue that it doesn't. Light abides by non-Euclidean laws. Since light abides by non-Euclidean laws, and we can perceive it, we can perceive things outside of three-dimensional Euclidean space. What does this mean? It means that we're not three-dimensional creatures. Because a three-dimensional creature could only be able to comprehend and fathom and view and perceive three-dimensional or lower events. We can perceive a point. We can perceive a line. We can perceive a three-dimensional object. If we are truly three-dimensional creatures, that should be all we are able to perceive. And yet, there's something that exists everywhere around us that we can perceive that does not abide by the geometry of what we are told we are. So, once you've taken out all possibilities that are doomed, Whatever remains, however improbable, must be the solution. So the solution is that we are non-three-dimensional beings. Whether this means that we are four-dimensional beings or higher-dimensional beings is yet to be seen, because this concept, though it's not exactly a new concept, requires a lot more work to actually come up with, solid, documented findings for. For so long, we've been known as three-dimensional beings. We've told ourselves we're three-dimensional beings. We've told our children we're three-dimensional beings. We've written in our textbooks that we are three-dimensional beings, and yet we're not. And we know we're not. But it's just a matter of what are we then? So since we're not three-dimensional beings, we exist in three Euclidean dimensions, but we exist in a dimension that's outside of this as well. So that's why I'm saying we're non-three-dimensional beings. So what this means is that Euclidean geometry, the geometry that we know, the way we understand the world around us, geometrically at least, does not hold for everything that we are. So that means that there's some sort of geometry that's non-Euclidean that we abide by. Now, non-Euclidean geometry is, to some people, kind of a joke. It's one of these, how do you know what non-Euclidean geometry is? Well, it's what we don't already have. And then people will say that you can just try to answer those questions with the geometry we have, and it always ends up going back to light. So basically, long story short, I could go so much farther into this, but long story short, we've been told that we're three-dimensional beings, and we're not. And light proves that we're not. So that means that what we truly are is split into two things. There's the three-dimensional Euclidean geometry, which it works. We can't argue that it doesn't work. It works for things that are three-dimensional in Euclidean space, or less. But there's another component, this non-Euclidean geometric component, and that part still has a lot to be discovered. So, the cool thing about non-Euclidean geometry is, since it isn't used, since it's not really something that's incredibly well known, its full applications aren't quite understood yet. So, non-Euclidean geometry, clearly, because this is the point that is creating non-Euclidean geometry in a sense, clearly it will answer questions about light. But there are other kind of unsolved ideas that people are interested in using non-Euclidean geometry for. How can we make superlight structures or superbuoyant structures? How can we create a structure that could be able to rest upon the surface tension of a body of water? Traditionally, you use physics which are based on Euclidean your three-dimensional Euclidean space, so they abide by certain rules. But if we can understand the parts of light that don't abide by non-Euclidean space, we can understand other aspects of the world that don't abide by non-three-dimensional Euclidean space, which means that there could be, uncertain, but there could be applications in literally everything. There may be a way to create a building that stands on the surface tension of a body of water. There could be a way to maintain surface tension of one part of a body of water, even if the surface tension on another part of the body of water is broken. There can be ways to much more simply travel long distances at great speeds. Traveling to the moon could become a simple thing. Traveling across the world can be done in less than an afternoon. You could theoretically come to a point where you can have lunch in Paris, dinner in Taiwan, and still be back home to tuck your kids in for bedtime. While none of this is guaranteed, while none of this is fully understood at the time, non-Euclidean geometry is something that really needs some more interest behind it. There's not that many people who are looking into it outside of basically theoretical mathematicians and physicists. So, just kind of a shout out to everyone that we are more than we've ever thought we were. We can be more than we ever thought we would be. and we're starting to discover that we're capable of determining things about ourselves that we never even thought were possibilities. And that's pretty dang cool. So, that's all for this time. Don't really know what I'm going to be talking about next time. I'm going to try to start making these somewhat regularly. A lot of them are just going to be like this, where it's not very prepared. Like, all I've done for this is open a tab, and I don't need to say that. I'll cut that out in post. Yeah.